We may have already found alien life, or we haven't. And the strange part isn't the discovery, it's that a year later, some of the best scientists on the planet still can't agree which. In April of 2025, a team of astronomers announced they'd found the chemical fingerprint of life in the atmosphere of a distant planet, a signal that, on Earth, is produced by exactly one thing: living organisms in the ocean. For a few months, this was, quite possibly, the biggest story in the history of astronomy. Then, other scientists looked at the same data, and the story got a great deal more complicated. Some now say the signal isn't there at all. Some say it's there, but might mean nothing. And earlier this year, a separate team pointed radio telescopes at the same planet, listening for something else entirely, and found silence. So, did we find it, or didn't we? The honest answer is the most interesting part of this whole story. The planet in question is called K2-18b. It sits 124 light-years away in the constellation Leo, orbiting a small, dim red star. It's about 8.5 times the mass of Earth, too big to be rocky like ours, too small to be a gas giant like Jupiter. Astronomers call this category sub-Neptune, which is less a description than an admission that we don't have a planet quite like it in our own solar system. What makes K2-18b interesting isn't just its size. It sits inside its star's habitable zone, the narrow range of distance where a planet is neither too hot nor too cold for liquid water. Some researchers believe it may be what's called a Hycean world, a deep global ocean sealed beneath a thick, hydrogen-rich atmosphere. Picture an entire planet that is mostly sea, with no continents breaking the surface, wrapped in air thick enough to trap heat like a greenhouse. It's a beautiful hypothesis. Nobody has proven it's true, but it was compelling enough that when the James Webb Space Telescope turned its instruments toward this planet, scientists paid very close attention to what came back. In 2023, a team led by Cambridge astronomer Niku Madhusudan published the first detailed look at K2-18b's atmosphere. The headline result was solid: methane, detected with enough confidence that few scientists argued with it, and carbon dioxide, detected almost as confidently. Both gases you'd expect on a planet with some kind of active chemistry going on. But buried in the same data was something smaller and far more provocative: a faint hint of dimethyl sulfide, DMS for short. Here is why that single molecule matters more than the others. On Earth, DMS is produced almost exclusively by one thing: marine phytoplankton, microscopic ocean life, quietly exhaling this compound as a metabolic byproduct. Find DMS on a distant planet, and you have found something no volcano, no lightning storm, no ordinary chemical reaction is known to produce on its own. The problem in 2023 was confidence. The DMS signal barely cleared what statisticians call 2 sigma, meaning there was roughly a 5% chance the whole thing was just noise, a coincidence in the data, nothing at all. Serious scientific claims are usually held to a much higher bar: 5 sigma, the gold standard, where the odds of a fluke drop to about 1 in 3.5 million. 2 sigma is not that. 2 sigma is a rumor, not a discovery. But it was a rumor worth investigating further. 2 years later, the same team came back with better data from a different instrument on the same telescope. And this time, the signal was stronger, roughly 3 sigma. Still short of the gold standard, but strong enough that the team went public, and the public listened. For a brief window, headlines around the world suggested humanity might have just found its first real evidence of life beyond Earth. Not a signal from a radio telescope, not a grainy photograph. A chemical trace sitting in starlight that had traveled 124 years to reach a mirror in space. It is worth pausing here to appreciate what that claim was actually asking you to believe: that a molecule made on Earth by ocean plankton had been detected, faintly, in the atmosphere of a planet so far away that the light we were reading left before most of your grandparents were born. That's either one of the greatest discoveries in the history of science, or an extremely elaborate coincidence. As it turns out, working out which one requires a great deal more patience than a headline allows for. Science, at its best, does not simply accept exciting news. It tries to break it. Other teams pulled the same raw data and ran their own analysis, and the cracks appeared quickly. A group led by Luke Wellbanks found that the same spectral pattern attributed to DMS could be explained just as well by ethylene, an unglamorous, thoroughly ordinary hydrocarbon with nothing to do with life. Swap one molecule for the other in the model, and the fit to the data didn't get any worse, which means the data, on its own, couldn't actually tell the two apart. Another independent analysis went further, testing multiple ways of processing the raw telescope readings. In the majority of those methods, 87.5% of them by one count, the supposed DMS detection simply didn't show up at all. It wasn't hiding. It was a product of one particular way of slicing the data and vanished under most others. Then, in January of 2026, a new paper delivered what may be the closing argument, at least for now. A reanalysis concluding that the original detection appears to have been, in the author's own words, a false alarm. None of this means K2-18b is lifeless. It means the specific piece of evidence that made headlines in 2025 has not survived scrutiny, which, frustrating as it is for anyone hoping for a simple answer, is exactly how this process is supposed to work. While chemists were busy arguing about ocean gas, another group of scientists tried a completely different approach. Instead of looking for the byproducts of life, they went looking for the byproducts of technology. In February of 2026, a team combined two of the most sensitive radio telescopes on Earth, the Very Large Array in New Mexico and the Meerkat Array in South Africa, and aimed them at K2-18b for an unusually long, carefully coordinated campaign. They weren't hunting for plankton anymore. They were listening for a signal, any narrow, artificial-looking radio transmission, the kind of thing a civilization with technology might, deliberately or not, leak into space. The scale of the search was enormous. Automated systems sifted through more than 20 million individual signals from the VLA alone, filtering out satellite chatter, cell towers, and the general electromagnetic noise every human civilization produces without meaning to. What was left, after all that filtering, was nothing. No transmission lined up with the planet's position. No signal repeated the way you'd expect if it came from K2-18b itself rather than from Earth. It is tempting to call this a disappointment. The lead researcher, Dr. C.D. Tremblay, was careful to push back on that framing directly, telling reporters plainly that the team did not conclude there are no technosignatures associated with the planet, only that within the frequencies and sensitivity they searched, none were found. A search this sensitive can rule out a very loud civilization. It cannot rule out a quiet one, or one that simply isn't broadcasting on a frequency we thought to check. So where does that leave us? A molecule that might have meant life, reduced, on closer inspection, to statistical noise. A radio search that found nothing, conducted by scientists who are the first to tell you that nothing is not the same as no. It would be easy to read this as a story about disappointment, a nearly there discovery that quietly fell apart. I'd suggest it's a story about something more useful than that. This is what honest science actually looks like while it's happening, which is messier, slower, and considerably less cinematic than the headlines that announce it. Nobody involved in this debate believes K2-18b has been ruled out as a candidate for life. They simply believe, correctly, that wanting something to be true is not evidence that it is. The Webb telescope will look again. Other instruments, more sensitive still, are already being planned. And somewhere in that patient, unglamorous process of double-checking and rechecking, real answers tend to eventually arrive, usually quieter and later than anyone would like. 124 light-years away, K2-18b is still there, orbiting its small red star, keeping whatever secret it has. For now, it's keeping it rather well. If you want to see what else science is still arguing about, subscribe. Next time, we go past another edge.